In this module, we will be looking at absolute values. Absolute values are denoted by the bars that we see right here. And what absolute values represent is the distance a number is from 0. Therefore, that distance is always positive. If we were taking the absolute value of 8, we can see that 8 is 8 units away from 0. And in looking at the absolute value of a negative 8, again, we see that we are 8 units away. That's why absolute value is always positive, because it is measuring a distance. So, will there ever be an answer to the problem 2x plus 1, the absolute value of that equals negative 9? And the answer is no, because our distance is positive, so we will never have a negative answer. In solving absolute value expressions, we want to first isolate that absolute value expression. Then we will be setting up two equations. In the first equation, we will drop the absolute value bars and solve. However, in the second equation, we'll be dropping the absolute value bars and negating the opposite side, because again, absolute values, we are looking at both the positive distance and the negative distance. So our first equation gives us the positive distance, and in the second equation, we'll be looking at the negative distance. Let's take a closer look. Here, we have the absolute value of 2x plus 1 equals 7. In checking to make sure that the absolute value expression is isolated, we see that 2x plus 1 is indeed isolated. So we'll be setting up two equations. In the first equation, I will drop my absolute value and look at that positive distance of 7. In my second equation, I'm going to be dropping the absolute value bars, but I want to look at what the negative distance away is, or if it was negative 7 units away. Now I will solve these two equations. In solving these two equations, I will start by subtracting 1, then dividing by 2. In my first answer, this gives me x equals 3. Again, subtracting 1 and dividing by 2, I now have an answer of negative 4. We should always double check that these answers make sense by plugging it back into the original equation, which we can do. So we would have the absolute value of 2 times 3 plus 1, which is 6 plus 1, or 7, so that checks out. And in the second equation, we would have the absolute value of 2 times the negative 4 plus 1. 2 times the negative 4 is negative 8, plus 1 is a negative 7. And we know the absolute value of a negative 7 is 7. So both our answers check out. In this next problem, we recognize that the absolute value expression is not isolated. Therefore, we begin by adding 7 to both sides, then dividing by 3, so that we can arrive at an absolute value expression that is isolated. Again, I'll be setting up two equations to solve this. The first equation, x plus 2 equals 7, and the second equation, x plus 2 equals a negative 7. Subtracting 2, I see that x equals 5, or x equals a negative 9. I would plug 5 and negative 9 back into my original equation to see if both of those answers are true. And in doing so, we find that x equals 5 and x equals 9, negative 9, are valid answers.